The last page of our notes has some real-life problems. Let's read through example 5. Which of the expressions shown represent the volume of the cylinder where r is the radius and h is the height? So here's the cylinder that we have. Here are the expressions that we're trying to identify whether they represent the volume of the cylinder. So r is the radius. I want you to notice that according to our picture, the radius is h over 2, because there's the radius of the base of our cylinder. They gave us a formula for volume that we're going to use. We've got 6 expressions over here. The first one, the only variable is r. The rest of them, the only variable is h. So notice our volume formula has 2 variables, r and h. We need to shrink it down to where we only have 1 variable. So I'm going to write it first in terms of just h, and then we'll write it in terms of just r. So if I'm going to write it in terms of h, I need to replace or substitute for the r, and we've got a nice little substitution. The radius is h over 2. So we're going to simplify that and see what we get. So square the numerator of the fraction, square the denominator of the fraction, and look at these as being over 1. Oh, let's see. That's going to be h squared over 4, and when we multiply that out, multiplying numerators, we have pi times h to the 3rd, because h squared times h is h to the 3rd, and 1 times 4 is 4. So one of the expressions is what we just found. Notice on this one, the denominator is wrong. That one, the denominator is wrong. This one, the power of, oops, not the denominator is wrong. The power of h is wrong, so that one doesn't work. This one, power of h is wrong. I want to look at that one. I want you to remember that 4 is the same as 2 squared, and a 2 squared in the denominator is the same as a 2 to the negative 3. 2 to the negative 2. It must be late. 2 to the negative 2. So that expression right there is also correct. All right, now let's do this using r. So using r. What I need you guys to notice is that if r is h over 2, then h is 2 times r. You get r by chopping h in half. You get h by doubling the r. So for that expression, using that expression, we can replace the h with a 2r. We'll reorder. We can do that when we're multiplying numbers and variables. So we have 2 times pi times r squared times r. So another expression for volume is 2 pi r to the 3rd. And 3 of them actually work for calculating the volume of that cylinder. Okay, we're going to move on to example 6. There's a little reminder of what it means to be written in scientific notation if you've forgotten. The jellyfish emits about 1.25 times 10 to the 8th particles of light, or photons. That's a lot of particles of light in 6.25 times 10 to the negative 4 seconds. And that's a really short amount of time. Those are both scientific notation, by the way. Its question we're answering is, how many photons does the jellyfish emit each second? Write your answer in scientific notation and standard. Well, if we want to know how many photons there are in a second, we need photons per second. That means we divide. We take the number of photons and we divide by the number of seconds, and then we'll have photons per second, which is what we want. So what we're going to do is we're going to rewrite that a little bit, and here it is, 1.25 divided by 6.25 times 10 to the 8th divided by 10 to the negative 4. And we'll keep rewriting. 1.25 divided by 6.25 is 0.2. And 10 to the 8th divided by 10 to the negative 4th, we can subtract exponents. Take the top one, subtract the bottom one. So 10 to the 12th, because 8 take away negative 4 is really 8 plus 4. So we have 10 to the 12th. That is not scientific notation, so we need to adjust a little bit. So 0.2, I need to turn that into a 2. I can do that if I multiply by 10. So I'm going to take the 10 to the 12th, write it as 10 times 10 to the 11th, and then I have 2 times 10 to the 11th photons every second. We're also going to write that in standard notation. Remember, when you multiply by 10, it just adds a 0. But we have to do that 11 times. So 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 3, 6, 9, 11. 200 billion photons each second is what we have. That is a lot of particles every second, a lot of particles of light.